Right. My name is Dr. G.V. Rao, professor in the Department of Civil Engineering, Vijnan Institute of Information Technology, Dovada, Vishakhapatnam. Today we are going to discuss about fluid kinematics. So before going to discuss about fluid kinematics, we should know what is fluid statics, what is fluid kinematics, what is fluid dynamics. The study of fluids, when the fluids are at rest position, the study is known as fluid statics. The study is known as fluid statics. When the fluids are in motion and the pressure forces are not taken into account, that study of fluids is known as fluid kinematics. Whereas when the fluids are in motion and also pressure forces are also taken into consideration, the study of fluids is known as fluid dynamics. Right? In this chapter, the fluids are first topic. In this chapter, the fluids are classified into different ways, that are steady flow and unsteady flow, uniform flow, non-uniform flow, laminar flow, turbulent flow, compressible flow, incompressible flow, and rotational flow and irrotational flow, and finally 1, 2 and 3 dimensional flows. These are the classification of flows in case of channels as well as in case of pipes. Right. What is steady and unsteady flow? Steady and unsteady flow. Steady flow is the type of flow in which the fluid parameters or fluid properties or that are the velocity, pressure, density at a point do not change with respect to time. The fluid parameters at a point do not change with respect to time. That is known as steady flow. Okay. So here, otherwise, this means that the fluid particles passing through a fixed point have the same flow parameters like velocity, pressure, surface tension, etc. Right? Another point, the parameters may vary different at different cross sections of the flow passage. At a point, the velocity do not change with respect to time, whereas the different points the flow parameters varies. Right? Mathematically, this steady flow is expressed as dou v by dou t is equal to 0. That means the flow parameter v with respect to t do not change. That means dou v by dou t is equal to 0 and dou p by dou t is equal to 0. The pressure with respect to time at any point or at a point do not change. Therefore, this is the dou p by dou t is equal to 0. And another parameter, dou rho by dou t is equal to 0. This is the one more parameter of the fluid, that is density with respect to time is equal to 0. This is about fluid, this is about steady flow. Right? dv by dt is equal to 0. Dou p by dou t is equal to 0, dou rho by dou t is equal to 0. Right, unsteady flow. What is unsteady flow? Unsteady flow, it is defined as the type of flow in which the flow parameters, that are the pressure, velocity, density, at a point changes with respect to time. At a point changes with respect to time. Suppose this is one pipe flow, this is the pipeline. At a point, this is at a point, the flow parameters velocity, pressure intensity and density changes with respect to time. That is known as unsteady flow. Mathematically, this is expressed as dou v by dou t is not equal to 0 and dou p by dou t is not equal to 0 and dou rho by dou t is also not equal to 0. That means the density at a point with respect to time changes. This is the mathematical expression for the unsteady flow. right? Dou v by dou t is equal to 0, dou p by dou t is equal to 0, and dou rho by dou t is equal to 0. This is about unsteady flow, right? Uniform flow means this is type of flow, this is one type of flow in which the fluid parameters, velocity, pressure, density, but basically we are going to take the velocity here, the velocity at a given time, okay, right? Uniform flow. Uniform flow is defined as the type of flow in which the velocity of flow at a given instant do not change with respect to space. In case of steady flow with respect to time, in case of uniform flow with respect to space, at a given instant do not change with respect to space, that is known as uniform flow, right? It is mathematically expressed as dou v by dou s is equal to 0. Earlier case, in case of steady flow with respect to time, here with respect to distance, okay? The flow parameter or velocity of flow at a given instant do not change with respect to space, that is known as uniform flow. This is mathematically expressed as dou v by dou s is equal to 0, right? This is the mathematical expression, right? Dou v by dou s is equal to 0. Here dou v is nothing but change in velocity, dou s is nothing but length of flow in a direction. Yes, suppose this is the one pipeline, this is the direction s, at we are going to take this is the reach of the channel, this is x distance or 100 meters whatever. So in this given reach, the velocity do not change with respect to space at a given instant, right? This is about uniform flow. Next one, non-uniform flow. Non-uniform flow is the type of flow in which the velocity of flow at a given instant change with respect to space. At a given instant change with respect to space, that is known as non-uniform flow. It is mathematically expressed as dou v divided by dou s is not equal to 0. Velocity at a given instant with respect to space is not equal to, is not constant, therefore this is equal to dou v by dou s is equal to 0, right? So dou v is the change in velocity, dou s is the length of flow in the direction of s. This is about non-uniform flow. Laminar flow is defined as type of flow in which fluid particles has definite path and paths of individual particles do not cross each other. In case of laminar flow having definite path and fluid particles not cross each other. That means the flow in the laminar flow is parallel and straight lines, right? And one more point related to laminar flow is also called streamline flow or viscous flow. Streamline flow or viscous flow. Viscous flow means that fluids are having viscosity that are the real fluids. Real fluids are the laminar flow having in case of smooth pipes, water flowing or liquids flowing through the smooth pipes, and also low velocities. And last point related to this laminar flow is it occurs in liquids having high viscosity. High viscous fluids are this laminar flow exists in case of high viscous. Next one, turbulent flow is type of flow in which the fluid particles do not have definite path, that is in zigzag movement, that are cross each other, okay? In case of turbulent flow, definite path, fluid particles are not having definite path and that are cross each other, and also that are in the zigzag movement. That this is about turbulent flow, right? And one more point related to turbulent flow and laminar flow. Laminar flow and turbulent flow are classified with respect to the R based on the Reynolds number. Reynolds number is the dimensionless parameter which is used for the classification of laminar and turbulent flows. Right, what is Reynolds number? Reynolds number Re is equal to rho V d by mu. Here rho is nothing but density of the fluid. Suppose fluid is the water, the density of water is equal to 1000 kg per meter cube, 1000 kg per meter cube. Like velocity of the fluid in the pipeline, diameter of the pipeline, and viscosity of the fluid. Based on the given parameters, based on the given values of density, velocity, and diameter of the pipe and viscosity of the fluid, we are getting some value. Reynolds number is equal to dimensionless parameter. We have some numerical value. That value, Reynolds number value, is less than 2000. That means Re is less than 2000. The flow is known as laminar flow. If the Reynolds number Re is more than 4000, that type of flow is known as turbulent flow. Some cases the Reynolds number value is in between 2000 and 4000. At that case, the type of flow is known as transition flow. This is about classification of flows, that are the laminar flow, transition flow, turbulent flow, based on the Reynolds number, right? Compressibility, compressible and incompressible fluids. Compressible fluid means the density of the fluid changes from point to point because of the variations of pressure and temperature. Okay, that means the density rho is not equal to 0. That fluid is known as compressible fluid. Now, in other words, density of the fluid is not constant. That is, the rho is not equal to 0. This is known as compressible fluid. Incompressible fluid. Incompressible fluid means the density of the fluid, that means rho, the density of the fluid do not change from point to point or from location to location because of the variations of the temperature and pressure. That is known as incompressible fluid. Here, in case of incompressible fluid, rho is equal to 0. Right. Here one more point, liquids are generally incompressible fluids. Liquids are generally incompressible fluids. Liquids means water, example. Liquids are generally incompressible fluid. Why? Here mass equal to, what is the formula? Mass equal to mass density, or mass density equal to mass by volume. Mass by volume. Here, because of the changes of temperature and pressure, there is less effect on volume in case of liquids. Whereas in case of gases, because of the change of pressure and temperature, have more effects on the volume of the gases. Therefore, in case of liquids, the density is equal to 0. Density is equal to 0 at any point over the reach, because of the effects of pressure and temperatures are very, very less on the volume, right? And another point, gases are compressible fluids, because same formula, mass density equal to mass by volume. So here, in case of gases, the effects of or the changes of temperature and pressure gives the high variations in volume. Therefore, mass density is also varies from point to point in case of gases. Right. Next property, rotational. Next types of flow, rotational and irrotational fluids. Rotational fluids means the fluid particles rotates about their own axis. Right, this is the these are the axis of the fluid particles that are rotates their about their own axis. There is no change rotation, there is no rotation change. Here also the fluid particles rotate about their own axis. This is known as rotational flow. Okay, whereas in case of irrotational fluids, the fluid particles rotates not rotates about their own axis. This is the axis of the here this is not same way. That means the fluid particles are not rotate about their own axis, flowing along the stream, that are known as irrotational fluids, right? Rotational fluids means the fluid particles are rotating about their own axis, so flowing along the stream, that is known as rotational fluids. Irrotational fluids means the fluid particles not rotate about their own axis, so during the flowing fluid in the stream, that is known as non-rotational or irrotational fluids. Next classification, 1, 2, 3 dimensional flows. What is one dimensional flow? What is two dimensional flow? What is three dimensional flow? Right. One dimensional flow, two dimensional flow, three dimensional flow. One dimensional flow is the flow in which parameters, that are the flow parameters, velocity, pressure, density, viscosity and surface tension, vary only in one direction, and flow is a function of only one coordinate axis. That means this is the x direction, this is the y direction, this is the z direction. If in case of one dimensional flow, the flow parameters velocity, pressure and density varies with respect to only one direction, that is only one coordinatal axis, that is x coordinatal axis, that is known as one dimensional flow. Are you clear? The flow field is represented by a stream which are straight and parallel. So in case of one dimensional flow, the flow represented by a stream that is straight and parallel, right? And mathematically this one dimensional flow is expressed as velocity is function of only in one direction with respect to time. This is the mathematical expression for the one dimensional flow. U is equal to function of x, that is only one direction, remaining two direction there is no changes with respect to t, right? This is the mathematical expression for the one dimensional flow. Next, two dimensional flow. Two dimensional flow means the flow parameters, that are the velocity, pressure, density, viscosity and surface tension varies with respect to two directions, that are varies only in two directions, so that is the function of two rectangular space coordinators, right? In case of two dimensional flow, the flow parameters velocity, pressure, density, viscosity and surface tension varies in two directions, that are this is x direction, this is y direction, this is z direction. But in case of two dimensional flow, the properties of the fluid varies in two directions, that is one is x direction and another one is the y direction. Therefore is a function of two rectangular space coordinators, that is in x and y direction. This is represented in case of stream flow which are curved shape, right? Mathematical form of the two dimensional flow is, that is equal to u is a function of x, y with respect to time. This is the mathematical form of the two dimensional flow. Next, right, three-dimensional flow. Three-dimensional flow means the flow parameters velocity, pressure, density, viscosity, and surface tension varies in three directions. Therefore is a function of three mutual perpendicular coordinates. Therefore, in case of three-dimensional flow, is a function of three mutual perpendicular coordinates, that is in x, y, z directions. Right? This is the one point. This is one direction. This is the one direction. This is the another direction. This is in the x direction. This is in the y direction, and this is in the z direction. In the x direction, the velocity is u. In the y direction, the velocity is u, and in the z direction, the velocity is w. In case of three-dimensional flow, the flow parameter, suppose here velocity is varies with respect to three directions, that is in the x direction, y direction, and z direction. The mathematical form of three-dimensional flow is that means u is a function of that varies with respect to x, with respect to y, and with respect to z with time. This is the one. In three-dimensional flow, u is equal to function of x1, y1, z1, and t, and v is the function of x, y, z, and with respect to t. This is the three-dimensional flow. In case of three-dimensional flow, v is equal to function of x, y, z with respect to time, and w is equal to, this is also function of x, y, z with respect to time. This is the mathematical form of the three-dimensional flow. Mathematical form of the three-dimensional flow that indicates that in case of a three-dimensional flow, the velocity component u, v, w exists in the directions of x, y, z directions respectively. Right? This is the u is the function of x, y, z, t, and v, that is the function of x, y, z, t, and w is also function of x, y, z, t. This is about one-dimensional flow, two-dimensional flow, and three-dimensional flow.